Hi, Intro to Algebra. Today we're going to review what we know about systems of equations and talk about 3 different things that can happen with number of solutions. So make sure you've got out wherever you're taking your notes here today. Alright, so here we've got 2 equations. We're going to graph them and see how many solutions we might have. So notice this top equation, we're going to have to either find the y-intercepts or put it in slope-intercept form. So I'm going to put it in slope-intercept form first. So here it is. I've subtracted 2x from both sides, and now I've got y equals negative 2x plus 6. That's for the top equation. The bottom equation I'm just going to leave by itself. So remember here we've got a slope of negative 2 and a y-intercept of 6. So that's this line. Its y-intercept is up here. Can't quite see it. But it goes down 2 over 1, down 2 over 1. This has the same slope but a y-intercept of negative 1. So how many solutions do you have here? Well, they never intersect. There's not a point on both lines. So when you have parallel lines, there are no solutions. So this has no solution. All right. What about this kind of a system? So for these 2 equations, we can either find the y-intercepts and x-intercepts and graph, or we could write in slope-intercept form. Since we did slope-intercept form last time, we're going to do x and y-intercepts this time. Okay, so I'm going to set up a little table. To find the y-intercept, we're going to plug in 0 for x. To find the x-intercept, we'll plug in 0 for y. And you can see here that I've plugged in 0 for x in this equation, and then I've got to divide both sides by negative 3. I didn't show that step, but we've got y equals negative 2. For the x-intercept, I put 0 for y, so you're going to get x equals 6. All right, something similar happens over here, but I've plugged into this equation to find the x and y-intercept. So you might notice that these tables look very much the same, and that's very true. When we go to graph these 2 equations using those tables, here's the y-intercept, here's the x-intercept, and we graph, these are the same line. They're overlapping lines. So every single point on this line is a solution to this top equation, and it's a solution to this bottom equation. So actually infinitely many solutions all along this line. Now, that doesn't mean that everything is a solution, so be careful about that. That's a solution. That's a solution, 3, negative 1. 6, 0 would also be a solution. Whatever this point is right here that I can't really tell, that's a solution. But not everything is a solution because only the points on the line are solutions. So anything over here is not a solution, and anything down here is not a solution. Try to think of a point that's not a solution. Okay, here are 2 that I thought of, right? Negative 2, 1, not a solution, not on the line. 1, negative 4, also not on the line, so it's not a solution. Okay, next system. Y equals negative 2, I've gone ahead and graphed that already. And then I'm going to have y equals negative 1/2 x plus 1. So let's graph that line. There it is. Now these 2 intersect in just one point. So these 2 have exactly one solution, and there it is, 6, negative 2. It's their intersection point. These are intersecting lines. Anytime you have intersecting lines, you have one solution. Okay, here's the big punchline of all of this. When you have no solution, that's because you have parallel lines. So parallel lines, no solution, they never intersect. When the lines intersect, we have exactly one solution. And when they are the same line or overlapping lines, we have infinite solutions. So go ahead and pause the video if you've been kind of just watching along. Go ahead and pause and write down this key slide. How can you tell how many solutions there are when you solve algebraically? So we're going to take an example here and solve it both by substitution and by elimination and see what happens. Okay, let's do substitution first. So I've taken this top equation and I've solved it for y. I added 3x to both sides and divided by negative 1. I've got y equals 3x minus 4. I'm going to take that, circle that, plug it in for the y. There we go. And now I'm going to actually do the substitution. So where I see y, I put 3x minus 4. I'm going to distribute. Now I've got negative 6x plus 6x minus 8. And I've got now negative 8 equals 8. Now is that true? Certainly not. right? And when you end up with something that's not true like that, that's no solution. What does that mean about these lines? So think back to that previous slide. If we've got no solution, what kind of lines are these? They are, in fact, parallel lines, never intersecting. Okay, let's do the same system, but we're going to do it with elimination, just to see how it is similar and different. I took this top equation, and I multiplied both sides by 2. And so then I canceled out. Well, it turns out both the x's and the y's canceled out. I got 0 equals 16. Certainly that's not true. So again, I see this as no solution. I've got parallel lines. Okay, another example here. You could do this by elimination or substitution. I'm going to go ahead and do it by elimination. So maybe I'll take this bottom equation and multiply by 3, and then it seems like those x's would cancel out. Great. So now I'm going to go ahead and add the two equations. I've got 0 equals 0, and that's true. So anything that works for this first equation is also going to work for the second equation. These are, in fact, the same line. So we have infinite solutions, all points on the line. Not anything in the world, not all real numbers, but all points on the line are solutions. These are overlapping. Okay, if you do the same thing by substitution, you're going to have to take probably the second equation and solve for x. That seems to be the easiest variable to solve for. Here we go, x equals 2y minus 4. And then we're going to take this and substitute it in where the x is. And go ahead and distribute, simplify, and what do you end up with? 12 equals 12, which is also true, absolutely. 12 does equal 12. So we know infinite solutions, all points on the line are solutions to this system. They're the same line, overlapping lines. Great. What you're going to work on now, and it's linked in your agenda, is the practice worksheet. You can print it if you want, but you don't need to. And by the time you look at these slides, I will have added the link. Awesome. Great job. Make sure that you do the 2 questions on Schoology, and then have an awesome weekend.